Hi guys, welcome back to my channel. This is episode 19 of AWS tutorials. In this video, we are going to learn how SQS batch size and Lambda concurrency control the speed of message processing. You will see how Lambda scales when we change the number of messages it receives and how many Lambda runs at the same time. So this is going to be our flow diagram today. Producer will send the message to SQS one by one and SQS will trigger Lambdas. So here we'll see what is batch size and how we can run multiple Lambdas in parallel to make the processing faster. So let's see how to do that. So guys, before starting the demo, let's see what is batch size and concurrency. So batch size is messages per Lambda invocations, means how many messages a single Lambda can receive from SQS in single invocation. And concurrency means how many Lambdas we can run parallelly to process the SQS messages. So guys, batch size and concurrency, these two decides the throughput of our processing system. So let's go to AWS console. So guys, let's create an SQS queue first. Create a queue. We'll create a standard queue and let's provide the queue name. There by Shashank, batch size and concurrency, demo SQS. And in the visibility timeout, let's select 1 minute. And just leave all the configuration as it is and create the queue. So guys, our queue is ready. Let's create a consumer Lambda. Create a function. Let's provide the function name. By Shashank, batch size and concurrency, demo Lambda. And in the runtime, let's select Python 3.14 and create the function. Our Lambda function has been created. So let's go to the code section. So guys, in this consumer Lambda, we'll do one thing. We'll collect all the messages that we'll receive inside this event object and we'll create a S3 file and we'll upload that file to S3 bucket. So let's implement that code. We'll remove this and let's read all the records from this event object. To read the SQS message, we just need the body of each record. So let's do one thing. So guys, now we'll append this body in a list. So let's create a list first. And we'll append that body inside this list. Now we have all the messages inside this list. So let's convert this list into a string that will going to be our file content. We'll join all the messages with /n. And now our file content is ready. Now let's create the file name. So guys, AWS request ID will going to be the file name. So we'll fetch the AWS request ID from context object. And let's add .txt in the end. So this is going to be our file name. And now let's upload this file to the S3 bucket. So for that, let's import Boto3 and create the S3 client. S3 client equals to boto3.client S3. And here we'll provide the bucket name. And now let's write a function. S3 client.put object, bucket equals to bucket name, key equals to S3 file name, and body will pass file content. And here I can log file uploaded successfully. So guys, our code is ready. We just need to put the bucket name. So let's create a S3 bucket first. Create a bucket. And let's provide the bucket name. Device chunk, batch size and concurrency, demo S3. And just leave all the configuration as it is and create the bucket. So guys, our bucket has been created. Let's copy the bucket name and let's configure this in Lambda. So guys, our code is ready. Now let's deploy this code. So guys, what this consumer Lambda will do, it will fetch all the records that it will get it from event object and will create a single file. So guys, every single Lambda invocation will create one file on S3 bucket. Now guys, let's do one more thing. Let's increase the timeout of this Lambda as well. We'll go into this configuration, click on edit, and here let's put 1 minute here and just save the changes. Guys, now we have to add the SQS trigger here. But before that, we need to provide SQS and S3 permissions to this Lambda because we are uploading the file to S3 bucket. So we'll need to provide that permission as well. Let's go into this permissions, open this role. Let's click on this add permissions, create inline policy. First, let's select SQS service. In action, we have to select receive messages. Second is delete messages. And third is get queue attributes. And in the resources, let's select all. Click next. Provide the policy name, SQS policy, and create the policy. So guys, SQS policy has been created. Now let's create S3 policy. We'll again create inline policy. This time let's select S3 service. In the actions, we need to search for put object. And resources, let's select all. Click on this next button. Provide the policy name, S3 policy, and create the policy. So guys, our Lambda role is ready. Now let's go to that Lambda and here let's add that SQS trigger. In the source, we'll select SQS and let's select the queue that we just created. Make sure this activate trigger is enabled. And now let's configure these three values. So guys, what is batch size? It is the maximum number of records that Lambda can receive in a single invocation. So in the first test case, we'll put batch size as 1 and we can leave batch window for now. And in the maximum concurrency, let's put 2. So guys, in this case, maximum 2 instances of Lambda can run in parallel. It is not mandatory that 2 Lambdas will run together. It is just the maximum value. And just leave all the configuration as it is and add the trigger. So guys, the trigger has been created. Here we have selected the batch size as 1 and maximum concurrency is 2. So what it will do, if we send 10 messages to this SQS, it will create 10 files at S3 bucket. So let's see how it will do that. And guys, there is one more thing to send the messages to this SQS. I have created a producer Lambda. So guys, this is the producer Lambda that I have created. So guys, what it will do, it will receive the number of messages from event and it will send that n number of messages to that SQS. And this is the JSON object that will send in SQS message and then message number. Okay. So here we need to provide the SQS URL. So let's copy the SQS URL from here. This is the URL, we'll copy it. And let's paste it here and deploy the changes. So guys, our flow is ready. Now let's test it. Let's click on this test event. So in the first test case, where batch size is 1 and concurrency is 2, I'm going to send 50 messages to this SQS. I'll invoke it. So guys, it has sent all the messages to that SQS. And now let's go to S3 bucket and let's see how many files that Lambda has created. We'll open this S3 bucket. And guys, if you see here, it has created 50 objects because we have sent 50 messages and the batch size was 1. So it has created 50 objects. So guys, let's open a file and see the content. Let's open it. So guys, if you see, this is the file content, message is 21. Okay. So guys, now let's delete all these files so that we can run the second test case. We'll select all the files and delete them. So guys, our S3 bucket is empty again. And now let's change the batch size. Here we'll click on this. Let's just refresh this. Let's select it and edit it. Guys, this time instead of 1, we'll put the batch size as 5. And now what does it mean? Our Lambda can receive maximum 5 number of messages in a single invocation. The minimum can be 1 and the maximum can be 5. So Lambda can receive from 1 message to 5 messages in a single invocation. And now guys, let's see what is this batch window. So guys, this is the maximum amount of time for which our Lambda can wait to gather sufficient records to create this batch size. So guys, let's say our producer is sending one message in 1 second. So here, if we provide batch window as 5, then in that case, it will wait for 5 seconds, and in that time, it will be able to collect 5 messages. So this is the maximum window so that it can send sufficient number of messages in a single invocation. Okay. So here in our case, let's put 10 seconds. So guys, this is just to reduce the number of invocations of a Lambda, and just leave maximum concurrency as 2 in this case. So here in this case, we have just increased the batch size to 5. And now let's save the changes. So it's getting updated here. Let's refresh it. Now the state is enabled. Now let's go to producer Lambda and send the messages. So guys, here again we'll send 50 messages, and this time Lambda will create less than 50 files. So let's invoke it. So it has sent all the messages. Now let's go to S3 bucket and let's refresh it. So guys, Lambda invocation is still going on. Let's refresh it again. So guys, this time Lambda has created only 11 files. So guys, if you see the size of the file here, the maximum size is 79 bytes and the minimum size is 15 bytes. Okay, so let's open this 15 byte file first. So guys, in this file we have only one message as 49, and let's open the file with maximum size. So here it's 79. Let's open it. And guys, here if you see, this file contains 5 messages because we have set the batch size as 5. So guys, this is how batch size works. It reduces the number of invocations. Now let's go to the Lambda and let's see one more matrix. Here we'll click on this monitoring. And here let's select last 15 minutes. So guys, if you see here in the invocations matrix, in the first test case, it executed 4 and 46. It executed this Lambda 50 times. Okay, that's why it created 50 files on S3 bucket. And this time in the second test case, it executed 9 lambdas, and let me just refresh this because it takes up to 2 minutes to refresh the values here. Let's refresh this. Yeah. So here if you see, it executed 9 plus 2, total 11 invocations of this Lambda. That's why in S3 bucket, we have 11 files. So guys, if you see here in this metric, total concurrent executions. So guys, in the first test case, it executed 2 containers parallelly. If you see here, the value is 2. And in the second test case also, it executed 2 containers parallelly. So guys, now let's increase the concurrency this time and let's see the difference. So let's go into this S3 bucket and delete all the files. And let's go to Lambda and increase the concurrency. We'll edit it. And this time, let's increase the concurrency to 5. So guys, in this case, it can run maximum 5 containers of Lambda parallelly. Now let's save the changes. Let's refresh it. So now the state is enabled. Now let's go to producer Lambda and let's send 50 messages again. So let's invoke this Lambda. So the Lambda has been executed successfully. It has sent 50 messages. Let's go to S3 bucket and let's see the number of files there. So guys, this time it has created 12 files. And if we see the minimum and maximum size, so the minimum size is 15 bytes. That means in this file we have one message and two files of 2 messages, and rest of the file contains 5 messages each. So let's open one file and let's see. So guys, this file contains 5 messages, and let's open the second file. So guys, this file contains only 2 messages. So guys, now let's go to the Lambda function and let's see the metric. Here let's select 15 minutes. So guys, this time if you see here, the maximum concurrent executions was 3. Okay, it can be from 1 to 5, but it won't exceed more than 5. Okay, so guys, in this demo we have sent only 50 messages, but in production generally this number is in thousands and in millions, and it is continuous because this time we have sent it only 2 or 3 times, but in production you receive the traffic continuously, and there it makes a huge difference on the batch size and concurrency. So guys, I hope this is clear to you now. So guys, this is how batch size and concurrency, these two together decide the throughput. So guys, if we increase the batch size, we can reduce the number of Lambda invocations. And if we increase concurrency, then our Lambda can process the message faster. So guys, this is why these two configurations are very important. Thank you guys for watching this video. In the next video, we'll see how to handle SQS partial batch failure. And if you like this video, please subscribe the channel and press the bell icon. And if you have any doubt, just put it in the comment box.